So today we're going to finish up chapter 5. So we'll be doing sections 5.4, which is counting. Okay, not quite as easy as, elementary school counting, but it is one of the most important parts of probability, is being able to count how many instances you have, because remember, that is usually part of the fraction that you use when you do probability. So we're going to look at the fundamental principle of counting. So fundamental meaning really important. So you will want to have your calculator out too. So you can go ahead and maybe pause the video and dig that out if you don't have it. But when finding the number of possibilities of multiple events, and apparently I don't know how to spell multiple. There's no M in multiple, well, in the middle. So when you have kind of one event after another, you can actually just multiply each of the number of possibilities for each individual event, and that will be the total number of possibilities for kind of the whole problem. Okay, so a lot of these types of problems actually show up on standardized tests like SAT, ACT, and college entrance exams. All right, so let's look at a scenario. So license plates in some states must contain 3 letters first, followed by 3 digits. Texas is not one of those states. Texas allows you to have really a pretty good mixture. So the question is, if this is a requirement for the state, then how many different license plates can be made? Because believe it or not, that's something they have to consider when they decide how they're going to do this, because they can't have 2 people having the same license plate, or, if there was a crime or something, or they needed to identify the car, you can't have 2 people with the same identification numbers. All right, so just kind of some basics. So there are 26 letters in our alphabet, right? There are 10 digits, so we're counting 0 as a digit, so 0 and then 1 through 9. So the number of choices for license plates, then, we are going to have 6 quantities that we're going to figure out. So if you read the problem, notice that the first 3 characters have to be letters, and we don't need to worry about going down by 1 every time, because we can repeat a letter twice. So you could have like an HH or something like that. Okay, so that's the first 3 characters. And then the last 3 have to be digits, so they each have 10 possibilities each. Okay, and if you were to multiply these out with your calculator, you'll get 17,576,000 choices. Okay. What you have to be on the lookout for, though, is kind of if we have kind of a with or without replacement scenario, like we talked about in class on Wednesday. So if there are 6 people that will be randomly ranked, how many choices are there for 1st through 6th place? And the important thing is that we are ranking them, so it would matter what order they were in. So we're going to look at some things today, but you want to pay particular attention to scenarios that where order matters versus where order doesn't matter, because our methods for calculating will be different. So we will have 6 numbers that will multiply together, but there will be 6 choices for the first spot, right? But then once that person has been placed, now we have one less person. So it's actually times 5 because one of the people are gone. And now 2 of the people are gone, so the third spot has 4 choices, and then so on and so forth. So notice what kind of happens is we actually just kind of reduce the number by 1 every time. And so here there are 720 possibilities. So the name for what we just did is called a permutation. And a permutation is basically the number of ways items can be ordered. So when order matters, when there's some sort of ranking, or when order is significant, then a permutation is kind of what we're going to do. So let's look at some notation. And you may have looked at this in another class. I'm not sure, to be honest, if you've covered this in any other class, but there is a symbol that we're going to use here for probability. So for any positive integer n, when you see this exclamation point, that actually means the word factorial. So what it means is you need to take the number times 1 less than the number times 1 less than that number, and you go all the way until you hit 2 times 1. Okay, like you literally go down by 1 until you reach the number 1. So let's just do kind of a brief example. So 4 factorial would be 4 times 3 times 2 times 1. And notice that's exactly what we actually did in that previous example. In example 2, we looked at 6 factorial. Okay, so we're going to talk about how that applies to permutations, but I want to show you how on most of the calculators where you can find the factorial button. So if you take out your calculator, even if yours is a little different than mine, you probably have a PRB button, which stands for probability. And so if I wanted to do 4 factorial, I would do 4 and then PRB, and then notice we're actually going to use number 1 and number 2, but number 3 is the one that I want because it has the exclamation point, and it will, let me move that over to where you can see it. It'll give you the answer of 24, which is what we got. Okay. Now you can also just manually do it, like 4 times 3 times 2 times 1, use the multiplication key, but we may be doing some numbers where it would definitely be helpful for you to know where that factorial button is. Okay. So kind of get out your calculator and maybe play around with that. The number of permutations, remember permutations we defined up above in the notes to be the number of ways something can be ordered, but the number of permutations of n objects is actually n factorial. Okay, so n times n minus 1 times blah blah blah. Okay, but there is a different type of process that we're going to use. Okay, and so if you see this notation, okay, now there will be a number in front and behind the P, and P does stand for permutation. So what this means is the formula for this is you do n factorial over n minus r factorial. So let me show you an example of that, but then I'm going to show you how you would use it. So if I told you 5 permutation 3, and so by the way, on your calculator, how you will enter that in is just literally read it from left to right. So let me get it in the screen. So you would do 5 and then go to your PRB, and then you will choose the first one, and then you will say 3. Okay, so literally you will do it in the order that it reads from left to right. Okay, but this would be actually 5 factorial because you take the first number factorial over the difference between the two of them factorial. So this is basically 5 factorial over 2 factorial. So let me show you what's going to happen a lot of times with these formulas we're going to use. So notice 5 factorial is 5, 4, 3, 2, 1, all multiplied by each other. 2 factorial is 2 times 1. And what's going to happen a lot of times is you're going to get a lot of cancellations. Notice the 2 times 1 can go away. So we end up actually just having 5 times 4 times 3, which is 60. Okay. So here's why that notation is significant and why we're going to use it. When you are taking or choosing R items from a larger group of N items, where order is significant or where order matters, it turns out that there are in permutation R possibilities. Okay, so really important that order is significant here, so let's look at an example. Alright, so this is used for when you have like a larger group that you're taking a smaller set out of. So let's say we have a committee of 9 people and they need to vote on their officers. So let's say that they want to choose a president, a vice president, and a secretary. And let's say that 2 of the 9 committee members, their names are Ellen and Joe. So I'm just kind of setting up the scenario. Okay, so the first question is, how many ways can a president, vice president, and secretary be chosen? In other words, out of 9, we want to pick 3 people. Okay, that is why it is this situation. Out of a big group of 9, we're going to choose 3 of them, or we're going to pick 3 of them. And it's significant that order matters. In other words, the reason order matters, even though they don't tell you that order matters, you know, it matters whether you're chosen for president, vice president, or secretary, right? It's not just 3 random, even-leveled positions. Okay, so president, you know, is different than the position of being chosen as the secretary. So if we want to know the number of choices, it will be 9 pick 3. And I say pick because it's a P. It's really more the permutation, but 9 permutation 3. So we'll do it on the calculator, but first let's write it out. So that looks like n factorial over the difference between them factorial. Okay, so that'll be 9 factorial over 6 factorial. Okay, and the 6, 5, 4, 3, 2, 1 in both are going to get canceled. So it's going to end up just being the 9 times 8 times 7, which is 504. Okay. Also, if you want to see what that looks like in the calculator, that would look like out of 9, I want to pick 3, and then notice you get the same answer. Oh, well, I guess it would help if I put it in view there, but you get the same answer of 504. Okay, so again, if you want to use the calculator, just enter it in from left to right. All right, so now let's combine this with some of the things we've talked about in this chapter already. So now I want you to tell me, what is the probability that Joe is the president and Ellen is the VP? Okay, So first we want to talk about the number of choices where this would occur. So my strong suggestion would be for you to come up with kind of 3 different slots here, because we have 3 different kind of scenarios, right? So the first one is Joe is president. Okay. The second one is we want Ellen to be VP. But then notice we actually don't care who is this last spot, right? So let's talk about kind of how many scenarios we have. So there's only one possibility where Joe is president. Okay, there's only one possibility where Ellen is VP. But then where we really need to think about is how many choices do we have now for this spot, right? So there are basically 7 choices left because there were 9 people. So there should be a 7 here, okay? So there are 7 ways that Joe and Ellen would be president and vice president, respectively. So here's where we answer the question then. So the probability of that happening then would be really nice if I could spell, but so the probability of that happening is basically the number of choices with Ellen and Joe. In other words, where Joe is president, Ellen is vice president, over the total number of choices. And using what we got in A and B, we actually have both of these. So there were 7 ways where Ellen and Joe were the VP and the VP and the president, respectively. But then there were 504 total ways that you could group those 9 people into 3 spots. Okay, so that reduces to 1 out of 72. And just pay attention to what Math Connect says as far as decimal places go. So I'm going to do this one to 5 decimal places, but on a test I'll always let you know how many decimal places I want, and Math Connect definitely lets you know. Alright, so when you want probability, you have to actually do a fraction. So let's do one more. So what is the probability that either Joe or Ellen is president and the other is VP? So notice we actually already know the total number of choices. It's still going to be 504, okay? But we need to know the number of choices where this occurs, right? So we want the number of choices where Joe and Ellen are either the president or the vice president. Okay, so kind of like we did on Part B, we still have 3 positions to fill. It's just a little bit different, right? By the way, this one is still, there's 7 choices for the last spot. That hasn't changed. Okay, but this time we don't really care who's president, right? So this is Joe or Ellen is president. So how many ways are there for that to occur? Well, there's 2, right? Because there's 2 people. So there's 2 ways for Joe or Ellen to be president. Okay, and then this would be the other one is VP. But notice, like, whether you pick Joe or Ellen here, only one of them is left for that second VP spot then, since we've specified that it has to be those 2, and then we can do times 7. So there's 14 ways to do that. So in the end, the probability is 14 over 504, which reduces to 1 out of 36. And again, let's just do it to 5 decimal places. Okay. So notice we have to come up with the count for how many options there are, and then we put that over the total number. Okay. So we use that NPR, the permutation type symbol, when we want to know how many choices there are when order matters. Okay. So the one that goes hand in hand with this, rather than a combination or a permutation, is a combination. And this is very close to a permutation, but it tells you how many possibilities for events where order doesn't matter. So the only difference between the permutation and the combination notation is order matters in permutation, order doesn't matter in combinations. So here is your notation. So in combination R, I like to say in choose R, okay, because out of n items you're going to pick or choose R items. But the formula here looks kind of close. It's n factorial over r factorial and then n minus r factorial. So the only really extra thing is this little r right here. Okay, so let's look at an example and then I'll show you how to punch that in the calculator, but it is almost exactly the same as the p version. Okay, so this is going to be 5 factorial and then over the second number factorial and then do the difference between them factorial. So it's like there's an extra factorial on the bottom. I think the formula here is pretty easy to remember because actually if you look at it, these two numbers will always add up to be the top number. So that's kind of how you figure that out. But let's go ahead and expand this out. So 5 factorial would be 5, 4, 3, 2, 1. 3 factorial would be 3, 2, 1. And then 2 factorial would be 2, 1. So notice 3, 2, 1 is gone. Okay. You could even cancel the 2 out if you wanted to, but what you end up getting is 20 on top over 2, which is 10. So if you remember right, 5 permutation 3 gave us a lot more options because order was significant. So if you want to see what that looks like on the calculator, again, you just read it from left to right. So you'll do 5, go to your probability menu and choose the one that looks like NCR, and then 3. Okay, so notice we got 10 there. Okay, just like we did when we did it on paper. So when taking R items, from a group of N items, where order doesn't matter, that's when you use this combination. There are N choose R possibilities. So the biggest factor that separates the two is whether order matters or not. All right, so let's look at an example where maybe order isn't so significant. So this will be example 4. So let's say that 10 college students have applied for an internship and 4 will be chosen. Okay, so my first question is, how many ways can the 4 students be selected? So notice, just like the permutations, we are picking a group of 4 out of a larger group of 10. Okay, so out of 10, we want to choose 4. But this time, you don't care if you're the first intern to be picked. There's no sort of ranking going on. So this time, order doesn't matter. So when order doesn't matter like this, like you wouldn't care if you were internship spot number 1 or 3 or 4, right? You still get the internship. That's really all that would matter. So if you want the number of choices, it will be 10 choose 4, 10 combination 4. So that's going to look like 10 factorial over the other number factorial, and then the difference between them factorial. Remember what I said, the bottom two factorials should add up to be the top one. So this will be 10 factorial over 4 factorial and 6 factorial. Okay. So again, if you want to, you can kind of expand this out. I would imagine a lot of you are going to use your calculator, and that's fine. But I still want you to kind of know how the process works in case your calculator isn't available to you, or in case you can't remember how to get it to work. Can't remember where that PRB menu is. So notice I've got 10 through 1 on top, and then 4 through 1, and also 6 through 1 on bottom. So what's going to happen is, you know, all of these go, right? And then if you want to, you also could kind of combine these. Like, for instance, 2 and 4 would take out that 8, right? Because 2 times 4 is 8. And then 3 takes out 3 of the 9. So you end up with 10 times 3 times 7, which is 210. Okay, so yes, I want you to be able to do it on your calculator, but I also want you to be able to write it out and kind of process that through as well. Okay, so let's look at another little subpart. Sorry, I'm looking for my supplies here. All right, so let's say that we're still in the scenario where we're choosing this internship. So let's say 8 of the 10 are from South Texas State College. So now I want you to tell me what is the probability that all 4 chosen are from Texas State College or South Texas State College. Okay, so I'm asking you for probability, which means we're going to need to consider something over 210, because 210 is the total number of ways that 4 students could be selected. So first we need to figure out the number of choices where what we want to happen occurs, which is we want the 4 to be chosen out of the 8. Again, notice that we don't care about order, so out of 8 we'd like to see all 4 chosen from that 8. So this is going to look like 8 factorial over 4 factorial, and then the difference between the two would also be 4. So this works out to be 70. Okay. So then to answer their question of the probability will be 70 ways where they're all 4 going to be from South Texas State, and then over the 210 ways that we got in Part A. So this works out to be 1/3. So if we're sticking with the 5 decimal place rule like we have been lately, then it would be 0.333 forever and ever. So I think one of the biggest things to get out of this section and to make sure that you keep straight is if order matters, use permutations. And if order doesn't matter, use combinations. And these are both, remember, for when you're taking a smaller group from a bigger group. Okay. You will always get more possibilities with this than you will with this, because when order matters, you'll have more opportunities or more options. Okay. So let's look at the last 2 problems that we're going to do today are really more of what I've seen on these standardized tests. It usually has something to do with food for whatever reason. So let's say that an ice cream parlor offers 19 flavors. And you're going big. You want a triple dip, and you want to sample 3 different flavors. You don't want to repeat any. Okay, so my first question is, how many ways can you order your cone? If it matters, if you're going to be really extra with the pour ice cream dipper, and it matters, let's say it matters which dip is on top. So in other words, you're not just going to tell them you want a triple dip, you're going to tell them the order that you want the scoops, which a little extra, but. Okay. So notice order matters, right? So since order matters, because we've specified that we care which dip is on top versus which one's on the bottom or in the middle, when order matters, we use permutation. So we have 19 flavors and we're picking 3 of those flavors. Okay, so that's what that looks like. So remember, permutation looks like n factorial over the difference between them factorial. So that would be 19 over 16 factorials. And so the 16 all the way down to 1 go away and you just get 19 times 18 times 17, or 5,814. Okay, so it's still a lot of ways to order your triple dip, right? So let's say you're not going to be so extra. So how many ways if the order of the scoops doesn't matter? Okay, so notice it's the same kind of problem, right? But this time order doesn't matter. So we're going to do 19, choose 3. So we're going to use the combination version instead. So that looks like 19 factorial over 3 factorial, and then the difference between them, factorial. So 19 factorial over 3 factorial and 16 factorial. So what you should end up getting is the 19, 18, 17 that you got in part A, but over the 3, 2, 1. So you get still a lot of choices, but less choices. You only have 969 choices. And then let's look at part C. So what if you didn't care about duplicating flavors? Okay. If you didn't care about duplicating flavors, notice that you don't really need the permutation or combination. You can just say this right here. So if you don't care about that, then it would just be 3 dips, and each dip would have 19 choices, since now we don't have to worry about going down by 1 every time. So we end up getting 6,859. So if duplications are okay, then it would be 19 cubed, basically, since there's 3 dips. Okay, so last example. So let's say that a 1 topping pizza can be ordered with 9 topping choices, three sizes, and 2 styles of crust. And so my question is, how many different 1 topping pizzas can be made? So if I want to know the number of choices, always pay attention to the problem. Notice I just asked you how many different pizzas could be made. I didn't ask you for the probability or anything like that. But the number of choices would be, according to the fundamental principle of counting, we just need to multiply these amounts. So I'm just going to come up with kind of 3 blanks for the 3 decisions I need to make. Okay, so first I've got size, I've got toppings, really in no particular order, and I've got crust. Okay, so there are 3 size choices, so we put that there. And then we're going to multiply by how many topping choices we have, so we have 9. And then how many crust choices we have, so we have 2. So the number of pizzas we could have is 54. So if I asked you, what's the probability of a customer choosing a medium pepperoni pizza with original crust? Okay, notice I'm being specific about size, topping, and crust, right? Then that would be 1 out of 54. Okay, so that's how you would figure that out. Okay, so I definitely want you to play around with the calculator. I want you to know the PRB button and know how to punch that in. Even if you don't have the calculator that I have, you probably have a probability menu. And so if you're having trouble finding it, you can Google it, or you could always send me a picture of your calculator and I'll try to help you find it. But you definitely need to know how to use your calculator here. But also you need to make sure you can do the calculations. Okay, so when you want to find more than one option, you can actually just multiply all the individual options.